Hi everyone. Today we are going to start first module in which the first lecture is about basic terminologies in electrical engineering. So first term is current. What is meant by current? It is the rate of flow of electric charges or simply the flow of electrons. So the equation for current can be written as I equals dq by dt, that is the rate of flow of electric charges. So q is the charge, so dq change in charge and dt change in time. Okay, so current is the rate of flow of electric charges. Unit of current is ampere, we all know ampere, and it is denoted as A. Then if we are considering a circuit, if q amount of charges is flowing through a conductor or are flowing through a corresponding point in a time t, then the current flowing through that point can be expressed as I equals q by t, that is charge divided by time. Okay, so this is meant by electric current. Then next term is voltage. What is meant by voltage or potential difference? It is the work required to move a charge through something or through an element. So potential difference or voltage is the work required to move a charge. If we need to uh, determine a voltage or potential difference between 2 points A and B, so it can be defined as it is the work required to move a unit charge from A to B. So it is the potential difference between A and B. Okay, then equation for voltage or unit for voltage or potential difference is volt, and it is represented as V. So equation for voltage is work divided by charge, work required to move a unit charge. So total work divided by charge will give the voltage. Okay, then next term is EMF or electromotive force. It is nothing but it is voltage itself, but there are some difference between voltage and EMF. EMF is the driving influence that causes a current to flow. Okay, it is something which causes the current to flow. That is meant by EMF. Okay, actually EMF means it is the voltage across a source or a battery. So it is the voltage across a battery. So if we are measuring a voltage across the source, we will term it as EMF. If we are measuring the voltage across any other devices, any other passive devices, it will termed as voltage. Okay, so one of the other difference is that voltage will be there only if there is a current. That is, if we are measuring a voltage across a resistor, to get a voltage, some current will flow through that resistor. Then only there will be some potential difference between that resistor. But EMF will be there without the presence of current. If you are taking a battery and measuring the voltage across its terminals, there will be some voltage, that is EMF. So EMF will be there in the absence of current, but voltage will present only in the presence of current. Okay, so unit is same as voltage, volt, but there is some difference between EMF and voltage. Okay, then next we are going to discuss about Ohm's law. Ohm's law means, or it states that at constant temperature the current through any conductor is directly proportional to the potential difference between its ends. Simply, the current is proportional to voltage at a constant temperature. Okay, so we can written as I proportional to V or V proportional to I, and we are replacing the proportionality by a proportionality constant R, and this R is called resistance. So V equals I into R, or V equals IR. So from Ohm's law we will get voltage is equal to current into resistance. Voltage is the product of current and resistance. Okay, then what is mean by resistance? Next term is resistance. Resistance means it is the opposition for the flow of current. Okay, we all know that. So it is the property of a material by which it opposes the flow of current. It is called resistance, and unit of resistance is ohm, and resistance is denoted by the variable R. Okay, this is the symbol for the resistance. And then next is which resistance depends on which all factors. Resistance of a conductor depends on it is directly proportional to the length of the conductor. That means whenever length increases, length of the conductor or length of the wire increases, resistance increases. Whenever length decreases, resistance decreases. Then resistance is inversely proportional to the area of cross section of the conductor. Area, that means area of the conductor increases, resistance decreases. Okay, so from these 2 points we can written as R is proportional to L by A, because since length is directly related and area of cross section is inversely related, so R is proportional to L by A. Or proportionality can be replaced with a proportionality constant rho. R is equal to rho L by A, where the constant rho is called resistivity or specific resistance. Here rho is missing here, where rho is called resistivity or specific resistance, and its unit is ohm meter, and the value of resistivity depends on the nature of the material. It will be constant for a particular material. If we are considering a conductor copper, it has some resistivity, it will be constant. Okay, resistivity will be depends on the nature of the material. Okay, and its unit is ohm meter. Ohm meter is because R is equal to rho L by A, so rho will be equals R into A by L. So unit of R is ohm, then A area is meter square, unit of L is meter. So meter and meter square, 1 meter will be cancelled from area, so unit of rho become ohm meter. Okay, and then this resistance. Then next term is conductance. Then conductance is just a reciprocal of resistance. It is the reciprocal of resistance. It is the measure of ease to the flow of current through a substance. It is the easiness of the current flow. It is conductance. Resistance means it is the opposition for the current flow. That's why we are saying conductance is the reciprocal of the resistance. Its unit is Siemens or mho. Okay, Siemens or mho, both are same. Then equation we already told that conductance G is reciprocal of resistance, so G is equal to 1 by R. We have already derived the equation for the resistance R is rho L by A. So we are replacing R with rho L by A. So again it become 1 by rho into A by L. This 1 by rho is replaced with sigma. So G become equal to sigma A by L, where sigma is called conductivity or specific conductance. Okay, its unit is mho per meter or Siemens per meter. Okay, so this all about conductance. Then next term is power. What is mean by power? We all know it is the energy delivered or dissipated per unit time, or it is the work done per unit time. Okay, work done per unit time, that is power is equal to work divided by time or energy by time, both are same. So power is work by time or energy by time, and its unit is watt. Unit of power is watt. It is denoted as W. Then we know that power is the product of voltage into current, voltage and current. So P is equal to V into I. According to Ohm's law, we know that I is V by R. So in this equation, I is replaced with V by R. So again power will be equal to V square by R. Then again in the first equation we are replacing V with I into R. According to Ohm's law, V is equal to IR. So V is replaced with I into R. So again P become I squared R. So for three equations are there for power. P is equal to VI, or P is equal to V squared by R, or P equals I squared R. Okay, so this is all about power. And the last term is electrical energy. We have already told power is equal to energy by time. So energy become equal to power into time. So energy equal to power into time. Unit of energy is joules. Or in electrical energy is commonly denoting or expressing with the unit kilowatt hour. Kilowatt hour is commonly electrical energy is denoting with kilowatt hour, the unit kilowatt hour. So energy we have already told power into time. So E become equal to VI into T, or E again equal to V square R into T, V square by R into T, or E again equals I square R into T. Then 1 kilowatt hour. What is the relation between kilowatt hour and joule? That is we are deriving here. 1 kilowatt hour, we are changing kilowatt to watt. So 1000 watt hour. 1 kilowatt means 1000 watt. So 1 kilowatt hour is 1000 watt hour. Then again we are changing hour to seconds. 1 hour means 60 minutes. 1 minute means 60 seconds. So 1 hour means 60 into 60 seconds. So 1000 into 60 into 60 watt seconds. Watt seconds is nothing but joule. Joule is equal to watt seconds. Okay, so watt second is joule. So 1000 into 60 into 60 joules is equal to 1 kilowatt hour. Okay, so this all about the basic terminologies in electrical engineering. Thank you.